According to start, this is something very interesting. Neural networks. BERT is these days. BERT is something which is used for text analysis, for text sentiment analysis, and part of speech and all. You use BERT, but I'm telling you a tool that is called NLU. With the 2 lines of code, you can get the things done, and that is very interesting. You have to use this command to first install it. So let's have it. It may take a little time, a minute or so, or maybe less. It doesn't take much time. If your net speed is good, then it won't take much time. We have few limitations with the collab because of the memory, but we will manage it. It's about 27, 28 seconds. It will tell you how much time we are consuming. It may take little time, but it's okay. Just 15 MB, nothing much. 15 MB is 6 seconds. Okay, that was done earlier. So let it install. Till then, I can type the code or put the code. Rather, I have code with me. So we have to load NLU. First, you have to install and then you have to load. Okay, so we'll be using pipe, and pipeline we'll be using. And what is pipeline? I'll explain it to you. And it is not recoverable. Access exiting now cannot. Okay. Spark is there. I'll have to install Spark separately then, but it's not required in this case. It will take just a few minutes. Done. Okay. Now you have to import NLU. Then in pipeline you see NLU.load sentiment. Now NLU actually is a project which was built in 1997, and since then it is actually used by many. 1997 it was BERT actually, and after BERT it came later. NLU, this tool came later, where they've actually combined the capabilities of BERT into one module that is called NLU. That is why we are piping it. Now, when we pipeline it, there's nothing like pipeline we have used, but actually there is more than one command which is called one, or rather you can say one more than one function which is called with when you load NLU. So we have used a variable called pipeline, but piping is something different, which I'll tell you. And piping actually is like running one code after another, something like that. Okay, so there will be more than one command. So whichever command you want, you can actually call it. But anyway, here what we are using is pipeline is NLU.load sentiment. Okay, we are using sentiment to find the sentiment from this. I love this document. It's so good. I can put any text, and I want to get the prediction how the text is, because what you say and what is written may be something different. So if you want to get the sentiments out of a text, you just have to put the text NLE.load the sentiment and then predict and just run it. Very simple to implement. It will tell you, it will tokenize. That's why it is in pipeline. Tokenization is breaking up the sentences into words or paragraphs into sentences depending on the use or the requirement. It takes time, and it actually loads a lot of things, lot of modules inbuilt. Okay, see, it is loading. Glove, it is loading. It is used. Okay, glove is there. I'll explain this later, but just see the implementation part. They are dictionaries, data dictionaries basically. Okay, you can see that. Now it has done everything for you. This is a positive sentence, you can see. It is telling you that it is a positive sentence. It has broken, it has taken this as two. Uh, and you can see the sentiment confidence, word emitting love. Then sentiment is there. I can try to expand it a little more and see the values. See the tokenization, everything, conversion, everything has been done, but you're not concerned with what is there. You can visit data table network and see output, sorry, or you can minimize the output again. Anyway, so this is what you get, and let's see some more examples. It's very simple, otherwise you have to do a lot. I'll show you later. Then neural network back propagation and all what we use in that. But for now, you can run this very simple command, and you can get the uh, sentiment, or if I want to get the emotion. Sentiment is positive, negative. Emotion is, let's see, how you're feeling about a thing. Whether the thing is positive or negative, you get from sentiment. Emotions will tell you the mood of the person. But it is so simple. Pipeline NLU.load emotion. Earlier it was sentiment. You can put the same sentence, or you can put a better sentence. You can replace the sentence you want, and then you can get things working. So if you're using something speech to text, also you can convert speech to text and then test whether what the sentiment of the person is using this technique. You can get text from anywhere and just find it directly without actually knowing the hard coding, which is actually into layers and all. We'll be talking about that, neurons and all, how they work, how the layers work. We can talk on that. But if you just want to implement it, this is very simple way of implementing. You can see that the emotion is joy, happy. Okay, very simple. Nothing you have to do. Just have to call the name. Okay, I'll just put some uh, text about it so that you can read and see what you can do. You can break it into chunks, or you can have the tokens, sentence, and documents. You can break the sentence also, and you can do a lot more than what it appears rather. Okay, so let me show you. If I want to predict the sentiment, all I have to do is, instead of putting it in pipe, I can put it directly. Also like this, I put some sentence nle.load sentiment dot predict, and then you have to give the output level, what type of level you want. So it will, it takes time. So it will be loading again, things which are not there. And if it is already loaded, then it will just skip. So one first time it takes time, you can see this now. Sentiment is positive, 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 and it has been broken. And this is a document type. You can see it is a document. It is not a chunk or a token. So it depends on me what type of output I want, and I'll show you the difference. If I use it and I just I'll change this only output level to sentence. I see that different sentence and this thing document would be more or less the same. We have chunk and the other options, the sentence, and this is the document. You can see it is much bigger. It is having all the text in every line. Here it is broken. All right, and let me see if I can run chunk on this also. I'll put the same thing, and instead of sentence or document, I'll put chunk. These are the levels, output levels actually. What you want? Very simple to implement. You don't need a hard coding. This is not for the coders. Coders won't like it, but it's okay. You can see that it has broken it into chunks. That is uh, a combination of sentences, one and two. Two sentences. It has broken into two sentences only. So you can have chunk, and this one more output. If I'm not wrong, that is token. So it will tokenize everything now. You can use this also. I'm not sure you take these things. Very simple to implement. There's always a question why non-programmers should be programming everything. Let this thing to be dealt by the poor programmers, and this is what it is all about. So you need see it has been broken in the sentences now broken down. It has been tokenized and vectorized actually. You can see you won't see any text here. You will see it here. You see the token. I love data. Everything has been broken now. And for every word you find that, whether it is positive or not positive, or whether it falls into negative, not. It's a very simple. So I don't have to understand what neural network is, how the nerves work, how the things work. What I have to do is just implement. As simple as that. Why would I like to have something like this? Okay. So this was sentiment, and you can have part of speech if you want. You can have a part of speech also, and instead of sentiment, what I can do is I can put EOS. I can have emotion also. You can experiment with things. I can share the documentation later. There's a lot of things you can do with it, but hard to find sometimes. This I'll have to share with you. Part of speech, proverb, verb, noun. We have to see proper noun, determiners, and all. Everything is broken up and shown. And if I just copy it, this will be more clear to you. If I make it token, I convert it into token, and then I have it as POS, part of speech. Now if I run it, you can see that it is running and loading with the required, and now you can see this token I is a proper noun, verb, noun again, noun, signs, proper noun, verbal nouns, verbs are there, helping verb is there, is MR, and so then we have the prepositions and all. Everything is defined. There is a list of it. The I have it. I think I'll share it with you. Then we have the positional parameters also, which I'll be taking later. It was just an example, and I can tell you NLU supports around 170 languages because it was updated earlier. It was 120. I think it supports 170 languages. You can try with other languages. The text in other language. Don't have to do anything. You don't have to convert, do anything. Just put the language you want to have and just run it. Right? Okay, anyway, uh, I'm waiting for the notebooks you can share with me, and some of the projects I don't find, so please share that also. Three are remaining. Akshat, I think, hasn't done it or hasn't shared, or maybe I don't have it. In the assignment, I'll check it again. But for now, let's meet on Tuesday. We have to meet on Tuesday, right? So you can play around with NLU and enjoy. You don't have to be a hardcore programmer to understand what the neural network is all about and how it works. Because for the thing which I have shown you in one line, you have to write a lot of lines to do that. You have to create the model, you have to do everything, and then you have to get that. But here you don't require anything, right? Easy. There are a lot of modules these days